Hello and welcome. Today we're going to start learning about what are called wings. We learned about X-wings in video number 10, but as I mentioned back then, an X-wing is not really a wing by definition. It is actually a fish pattern, like a swordfish or a jellyfish. A real wing is a configuration that looks kind of like its name implies. It has a central component, which can be a cell or a conjugate pair or a subset, for instance, and then it will have two arms that branch off, one on each side, like two wings. Some people call the central part the pivot and the two arms or wings the pincers. And I'm okay with these terms for lack of anything better. So let's go over to the puzzle board and see what these things look like. I will cover three types of wings here in the complete course: XY wings, XYZ wings, and W wings. I will cover WXYZ wings and wings constructed with almost locked sets in my advanced series, as they are a bit more complicated and are not really necessary to solve most puzzles. XY wings and W wings are each nothing more than a very specific kind of an AIC Type 1. An XYZ wing is a little different and has its own logic, even though it is composed of a pivot and two pincers, just like the other two. But today we will focus entirely on XY wings. If you watched my video number 18 on bi-value cells, then you will already have a head start on today's lesson. An XY wing is composed of exactly three bi-value cells. The letters X and Y simply refer to the two random candidates in any of those bi-value cells. And the three bi-value cells will always incorporate the use of exactly three candidates chained together in an AIC Type 1 of 5 links: strong, weak, strong, weak, strong. And without intending to unnecessarily confuse you all, I am going to refer to those three candidates as A, B, and C, okay? So don't confuse this with the X and the Y. XY wing is only the name of the configuration. But to explain this, it will be easier to understand if we use A, B, and C to denote the three candidates. Don't worry, you'll see what I mean in just a minute and it will all become crystal clear. In an XY wing, the middle bi-value cell, or the pivot cell, will contain the candidates that we will call A and B. So let's say this cell, R3C5, is our pivot cell. And so in this example, the 1 and the 3 are candidates A and B, okay? Now one of the two wings or pincer cells will contain candidate A coupled with a third candidate, which we will call candidate C. And the other pincer cell will contain candidate B, also coupled with candidate C. And of course, here in this example, candidate C is 9. So an XY wing will always have a configuration that looks like this: three bi-value cells with candidates A, B, and C. A, B, and C can of course be any three candidates, but in the example we just saw, A is 1, B is 3, and C is 9. So the pivot is 1, 3, and one pincer is 1, 9, and the other pincer is 3, 9, okay? There is a strong link between the two candidates in any bi-value cell. And if you remember from video number 4, an AIC Type 1 will always begin and end with a strong link. It will also have an odd number of links, and it will start and end with the same digit candidate. And when we construct the chain like this, we know with absolute certainty that one of those two endpoints must be true. Now, if you are unsure about that, please go back and watch videos number 3, number 3A, number 4, and number 4A. So in an XY wing, the two endpoints will always be the two candidate C's, which will always be the two extremities of the chain. So here is how these candidates link up: strong, weak, strong, weak, strong. Let's draw the chain. I'm going to use simple lines instead of arrows because there is really no direction to this. You can start on either end or you can start in the middle on the pivot cell. It makes no difference. Strong links will be blue and weak links will be green. The 3 strong links are all within the cells, and the 2 weak links are between the cells. So once you find your pivot cell with A and B, you need to link that cell to another bi-value cell containing A and to another bi-value cell containing B. And then each of those pincer cells must contain the common candidate C, one coupled with A and the other coupled with B. Each pincer cell must share a house with the pivot cell. Otherwise, you would not be able to link them. You see, AC is in the same block with AB, and BC is in the same row with AB. But the 2 pincer cells will obviously be in 2 different houses. Otherwise, you would simply have a naked triple, like this. So the shape of an XY wing will always be angular or bent. It will never lie in a straight line. The links between the cells only need to be weak, like the link between the 2 candidate A's, the 2 ones up in block 2. That only needs to be a weak link. So it makes no difference how many other instances of candidate A lie in that same house. That link can be weak or strong. There could be additional ones up here in this block, but the link between the ones and the 2 colored cells only needs to be weak, so you don't even need to pay attention to that. As long as candidate A is linking to another candidate A in another bi-value cell in the same house, it will work. And then the same thing is true on the other side of the pivot with candidate B. There could be other 3s in row 3. And that will not affect the weak link between the 2 3s in the colored cells. So the whole point of this is that one of the 2 candidate C's, meaning the 2 endpoints of our chain, in this case the 2 candidate 9's, must be true. Therefore, any other same-digit candidate that can see both ends of the chain, i.e. both candidate C's, can be eliminated as false, just like a turbofish, a 2-string kite, or a skyscraper that we learned about in videos number 14, 15, and 16. And if the 2 endpoints lie in 2 different chutes, then there will be only one possible elimination. Like here, there's only one place that you could eliminate a candidate 9, and that would be right there. That candidate 9 would be false because it can see the 2 9's in the light blue cells. Now there is one other cell that sees both of those 9's, and that is row 3, column 5, but that's our pivot cell, so there can't be a 9 in there, otherwise this would not be an XY wing. So that can't be there. But if the endpoints lie in the same chute but not in the same house, there can be up to 5 eliminations, like this. If there were a 9 in any of these 5 cells, they would be false. Even though there are 6 cells that can see both endpoints, there cannot be 6 possible eliminations because the pivot cell will take up one of the spaces. And of course, there cannot be a candidate C in the pivot cell, otherwise there would not be a strong link in that cell and you would not have an XY wing. And as I mentioned earlier, if the 2 endpoints lie in the same house, then it will be a naked triple, like this, which would allow you to eliminate all other instances of A, B, and C in that house and not just the other candidate C's, capiche? And this would be the case even if the particular house is a block, like this. You could eliminate all 1, 3's, and 9's from the rest of that block. So let's go back to the chain. Strong, weak, strong, weak, strong, 5 links. Same candidate on both ends, starts and ends with a strong link. One of the endpoints must be true, so any same-digit candidate that can see both ends of the chain must be false and can therefore be eliminated. But when you are solving puzzles, you don't need to think about all this stuff. All you need to do is identify 3 bi-value cells with 3 candidates and hook them up like this, And you will know that one of the endpoint candidate C's must be true, and then immediately make any possible eliminations. You don't have to think of this chain in such detail each time. Once you understand this concept, you can just spot a by-value cell and then connect one of those candidates to another by-value cell, and then connect the other candidate to yet another by-value cell, and the two pincers must have a common third candidate, and voila, you've got an XY wing. And any other same-digit candidate that can see both endpoints, i.e. the two candidate C's, can be eliminated as false. Got it? Great. Okay, so let's take a look at some real examples and some real puzzles. All right, so what we're looking for is three by-value cells that incorporate the use of three candidates, A, B, and C, with a pivot cell containing only A and B, and then two pincer cells containing AC and BC respectively. Each pincer cell will share a house with the pivot, but the pincers will not be in the same house, otherwise it would just be a naked triple, as I explained earlier. For this first example, in addition to highlighting the candidates, I will label the cells and draw the chain to demonstrate this as clearly as possible. And then after that, we'll do it in a more streamlined fashion, okay? So here in this puzzle, we've got a pivot cell right here in row 3, column 1. Candidates 1 and 6 are A and B. It doesn't matter which is which. Now let's call candidate 1 our candidate A. And down here in row 5, column 1, in the same column as the pivot, we've got another by-value cell with candidate A coupled with a third candidate C. And so, of course, our candidate C is 9. And then up here in row 1, column 3, in the same block as the pivot, we've got candidate B, which is 6, coupled with our same candidate C, which, as we know, is 9. So these three cells form an AIC type 1 of 5 links, from one 9 to the other 9. And remember, you can start on either end of the chain. So let's start on candidate C up here in block 1 and highlight the candidates. We'll alternate blue and yellow to denote the links. So we've got strong, weak, strong, weak, strong. This ensures that at least one of those endpoint 9s has to be true. So any candidate 9 that can see both of those endpoints must be false. And in this puzzle, there are 3 of them. There's one here, there's one here, and there's one here. Those 3 red-colored 9s can see the 2 endpoints. Notice that these 2 9s do not see both endpoints, and so the XY wing has no effect on them. But the 3 candidate 9s colored in red are false, and you can eliminate them, just like that. Okay? So let's put them back in, and let's draw the chain. Strong links will be blue, and weak links will be green. So we've got a strong link from this 9 to this 6. I'm going to have to draw it like that. And then we've got a weak link to this 6, a strong link to this 1, a weak link to that 1, and then finally a strong link to that 9. Notice that the strong links are all within the cells and the weak links are all between the cells. The weak links can be either weak or strong because we know that a strong link can act as a weak link. So you don't even need to test those weak links. As long as the 2 by-value cells can see each other, i.e. as long as they are in the same house, it doesn't matter if there are other instances of the linked candidate in that house or not. So there's your XY wing. Either the blue candidate 9 in row 1, column 3 is true, or the yellow 9 in row 5, column 1 is true. So any other candidate 9 that can see both endpoints of the chain must be false. And there can be up to 5 possible eliminations, but here there are only 3. Got it? Okay, let's go to the next one. All right, here in this puzzle, our pivot cell is row 6, column 9. And then we've got 2 pincers, one here and one here. So A and B are 6 and 9. And up here in row 1, column 9, we've got 6, 4. And in row 6, column 3, we've got 9, 4. So here's our chain. We've got strong, weak, strong, weak, strong. So the two endpoints are the candidate 4s, and that means any other candidate 4 that can see both of those 4s will be false. And because the two endpoints are in two different chutes, there's only one place that can happen, and that is right here. So you can eliminate that 4 as false because it can see the two endpoints. All right, next one. All right, in this puzzle, here's our pivot cell, and here's one pincer and the other pincer. We've got 1, 3, and 7, 3. So any candidate 3 that can see both of those endpoint 3s will be false, and in this puzzle there are 4 of them. We've got 1, 2, 3, and 4. Those are the only 4 3s that can see both endpoints, so you can eliminate all 4 of those as being false. All right, let's go to the next one. All right, here's our pivot cell. 2 and 6 are candidates A and B, and up here we've got 2, 1, and over here we've got 6, 1. So 1 is our candidate C, and now we can eliminate any candidate 1 that can see both of those 1s. And in this puzzle there are 2. There's one here and one here. Those can both be eliminated as false. All right, let's go to the next one. All right, here's our pivot cell. 8 and 6 are candidates A and B, and we've got 6, 9, and we've got 8, 9. So 9 is our candidate C in those two light-colored cells. So any candidate 9 that can see both of those 9s will be false. And here there are 3. 1, 2, 3. Those 3 candidate 9s are false. All right, next. Okay, in this puzzle, here's our pivot cell, 3 and 6, and then we've got a 3, 2, and a 6, 2. So candidate C is 2. And any candidate 2 that can see those light-colored 2s will be false, and in this puzzle there's only 1 because the 2 pincers are in 2 different chutes. And that's the 2 right there, so you can eliminate that 2 as false. All right, let's go to the next one. All right, here in this puzzle, our pivot cell is in row 4, column 1. Candidates A and B are 1 and 7. And then we've got 1, 5, and 7, 5. So candidate 5 is candidate C, and that means any candidate 5 that can see both of those light-colored 5s will be false. And again, because the 2 pincers are in 2 different chutes, there can only be 1, and it's right here. This candidate 5 is false and can be eliminated. All right, let's do one more. Okay, here's our pivot cell in row 5, column 7, and here's our 2 pincers. So candidates A and B are 4 and 6, and candidate 9 is candidate C. So any candidate 9 that can see both of those light-colored 9s in the pincer cells will be false, and in this puzzle there are 2. There's one here, and there's one here. So those can both be eliminated as false. And as I mentioned before, there can be up to 5 eliminations, but in this puzzle there were only 2. All right, so that was 8 examples, so I don't think there's any need for an adjunct to this video, and we'll do the same thing for the XYZ wings and the W wings. Okay, so that's going to do it for today, so let's go back outside and finish up. Thanks for watching. Okay, there you have it. Those are XY wings, and they are one of the most commonly occurring patterns in puzzles of any difficulty level. A little later on in the course, we will learn about XY chains, which are just like XY wings, except that there can be many more bi-value cells linked together than just 3. But the principle is exactly the same. In the next video, video number 24, we will learn about what are called XYZ wings. Even though the name is similar to an XY wing, an XYZ wing works on an entirely different principle. But they are very easy to understand, as you will see. So I hope you will join me for that lesson. In the meantime, be well and be happy.